Section 6.2 is called using the normal distribution, and basically all it involves is some examples that we're going to work together on how we can answer probability questions, how we can find things like percentiles. So in example number 1, we have final exam scores in a stats class. The mean is 63 and the standard deviation is 5, so those are pretty bad scores. Here are the 3 questions that we're going to answer. We're going to move over to the document camera to answer these questions. 2 about probability and 1 about a percentile. Alright, so example number 1, we have some final exam scores with a mean of 63 and a standard deviation of 5. So not very good exam scores, but good material for this question. Part A asks us to find the probability that a randomly selected student scored more than 65. So we're trying to find the probability that an individual score would be greater than 65. So there's a couple ways we could go about doing this. So I'm going to solve this problem using the calculator. I figure that's probably the more common way that you guys will want to do this. So what we'll do is we will put in our calculator in normal CDF, so second vars, normal CDF is number 2. Our lower value, since we're dealing with a greater than, our lower value will be 65. Our upper value is technically infinity, right? But we tell the calculator 1e to the 99th. And then we'll change mu to be 63 and sigma to be 5. Okay, this is basically the minimum amount of work that we could do to solve this problem. So the probability here is 0.3446. So the only downside to doing the problem this way is that it's not very instructive. It doesn't tell us a lot about what's going on. So just as a second run through here, what if instead we wanted to turn this into a z-score? So to do that, we would take our x value, which is 65, minus our mean, 63, divided by our sigma, which is 5. And we'd get 65 minus 63 is 2 over 5, which is 2/5 or 0.40. All right, so now let's think about what's happening in terms of the distribution. Okay, remember we have this bell curve. Okay, right in the middle of the bell curve is 0. And what we are dealing with is a z-score of 0.4. So if this is 1 and this is 2 and this is 3, then we're somewhere right about here at 0.4. And so the question's asking about the probability that we're greater than this, which is equivalent to asking the probability that z is greater than 0.4. Okay, in this context, x greater than 65 is the same as z greater than 0.4. So that means we're looking for the area in this part of the bell curve. Okay, remember that with continuous probability distributions, area is equivalent to probability. So we already know the answer to this, but what we could do now is we could either go to normal CDF in the calculator, or we could use the table that I showed you in section 6.1, and either way we should be able to come up with 0.3446 for the area of this part of the normal curve, which is equivalent to the probability either that x is greater than 65 or that z is greater than 0.4. Okay, whichever way you prefer to think about it. I think dealing with z-scores gives us a little more information. It helps us connect what's going on to other problems. Find the probability that a randomly selected student scored less than 85 is part B. So a couple ways we could go about this. Again, we can just use the calculator, and this time because it's a less than, we do normal CDF. Our lower will be -1 e to the 99th. Our upper will be 85. Now mu is still 63, sigma is still 5, and we get 0.99999. So very, very high probability that an individual scored less than 85. So again, we could convert this to a z-score, sketch the graph. I think sketching the graph with these bell curves is very often useful. It helps us to keep in our minds what it is we're dealing with. So 85 minus 63 is 22. 22 over 5 was 4.2, I think, maybe 4.4. Okay, so this is a high z-score. Okay, anytime you get a z-score over 3, you're dealing with something pretty high. So the probability that z is less than 4.40 is 0.99999. All right, so again, I didn't draw the graph this time, but converting to a z-score, seeing what that z-score is, I think is helpful in helping us to understand why this probability is so high. All right, so the last question on example 1 is to find the 90th percentile. Okay, we want to find P90. So again, a couple ways to do it. Probably the quickest way is to go to second vars to that distributions menu and go to INV norm, the inverse normal option, and tell it that we have an area of 0.9. Our mu and our sigma are 63 and 5 still, so we put those in, enter, and we get 69.4 as our 90th percentile score. So it's possible that, you know, there may not be any decimal grades. You know, if this teacher, professor, or whatever just goes to the nearest whole number, then you might want to round that up to 70. You would not round it down. It seems like it would be a number you'd round down, but for percentiles, we always want to round it up to make sure that we truly get higher than 90% of the other values. So that wraps up example number 1, and we'll head back to see what example 2 holds. In example number 2, we have household PC usage for entertainment. We're told the mean is 2 and the standard deviation is 1/2. So we'll switch back to the document camera to answer these 2 questions. First one is the probability that a PC is used between 1.8 and 2.75 hours. And then the second question is another quartile question. Example number 2 has to do with household computer use for entertainment. This is several years old, so I would imagine these numbers, if they were ever accurate, are probably not accurate anymore, but it says that the mean is 2 and the standard deviation is 1/2, or 0.5. So this is in terms of hours. Okay, so the mean is 2 hours, standard deviation is half an hour. Part A asks us to find the probability that the household PC is used for entertainment between 1.8 and 2.75 hours per day. So again, calculator is maybe the preferred method here in terms of speed. Our lower is 1.8, our upper is 2.75, and our mean is 2, standard deviation 0.5. We get a probability of 0.5886. Again, we can convert these to z-scores. We'll have to do it twice for this one. 1.8 minus 2 over 0.5 will give us, let's call it z1. And then our second z-score will be 2.75 minus 2 over 0.5. So this is negative 0.2 over 0.5, so that should be negative 0.4. Yep. And 2.75 minus 2, that'd be 0.75 over 0.5, 1.5. So the question here is basically asking us the same thing as finding the probability between a z-score of negative 0.4 and a z-score of 1.5. Okay, so we're looking for the area in this region here in the middle of, well, partially in the middle of this bell curve. Okay, so we're leaving out the tail over here and we're leaving out this tail over here. We just want the stuff in the middle. So we've already done the calculation, but if you wanted, you could go to the table and you could look up the area to the left of negative 0.4, and you can look up the area to the left of 1.5 and just subtract those two values, and it should give you something pretty close to 0.5886. Sometimes we get slightly different numbers depending on whether or not things had to be rounded and whatnot, but it should be very close to that. So again, this is equivalent to x being between these two numbers is equivalent to z being between these two numbers. Either way, we should get the same result. Part B, find the maximum number of hours that the bottom quartile of households use as a PC for entertainment. So we're trying to find the lower quartile, or Q1. And remember that the lower quartile is equivalent to the 25th percentile. Right? The bottom quarter is the same as the bottom 25%. So just like we did on example 1, we can go second bars inverse normal. We put in 0.25. We put in our mean of 2 and our standard deviation of 0.5. And we get 1.663. Let's call it 1.66. That's probably good enough. So 1.66 is our Q1, or our 25th percentile. The other way to go about doing this would be to look in the table, and looking in the main body where all the numbers are, you want to try to get as close as you can to 0.25. So I'll go back to our slides, or go back to the browser, and we'll look at see if we can find that value in the table and see how close we get to 1.66. Okay, in our standard normal table here, we are looking for the value in the main body of the table that is as close to 0.25 as we can get. So I'm scrolling down. I'm on the first page here where we have negative z-scores, and I'm going to look for the number that's as close to 0.25 as I can get. So looks like right here we jump from 0.251 to 0.248. So right in there would be our best answer. So we're at negative 0.6, let's see, scrolling up, negative 0.675 is what it looks like. So what we would then do with that is we would take our negative 0.675 and convert that back into an x value. So to do that, we set up z equals x minus mu over sigma, and we solve for x. Okay, z will be this value, negative 0.675, and we know our mean is 2 and our standard deviation is 0.5. So when you solve for x, we should get 1.66, or pretty close to that, that we got when we just used the inverse normal in the calculator. Your suggested homework comes from the practice section. 48 to 59 should be enough, I think, to give you a pretty good set of practice using the normal distribution to answer probability questions and percentile questions and stuff like that. So please let me know if you have any questions, and good luck on this.